So starting to look at mechanics problems, we have problems like this. A car starts from rest and accelerates uniformly over a time of 5.21 seconds for a distance of 110 meters. Determine the acceleration of the car. So to begin these problems, there's a step-by-step process for doing these problems. You begin usually by writing V, U, A, S, T, like this. Now, T is time, S is the displacement or the distance, depending on the problem, A is the acceleration, U is the initial velocity, and V is the final velocity. So what we're going to do is we're going to read through the problem, we're going to pull out the information that's in the problem, and we're going to put that into the, fill them in here. So let's see, a car starts from rest, so that means that the initial velocity here is 0 meters per second, and accelerates uniformly over a time of 5.21 seconds. 5.21 seconds. For a distance of 110 meters, so S is the distance, so it's 110 meters. And you have to find the acceleration of the car. Alright, so the next step, that's step 1 done. And if we look down here, we see that everything's in SI units. We're meters per second, we're in meters, we're in seconds, everything's good. So we start next by doing the equations of motion, so we write those out. V is equal to U plus AT. V squared is equal to U squared plus 2AS. And S is equal to UT plus a half AT squared. Okay, so the next thing we do after that is we look down through this list and we put a line under anything we have. So we have U, so let's find anywhere where there's a U in this where we can fill in values, okay? We have S, so we can go back to our equations here, we can put a little line under S. And we have T, so anywhere we can find a T, we can mark it in. Now, next we look at equations here where we only have one variable left that we don't have a value for. So for instance, in this equation we have V, we don't have that value, and A, we don't have that value. So here we have one equation and we have two unknowns. So that's not very good. We can't really solve for anything there. Here we have V squared, again, V term here, that we don't have the value for it. We have A here as well, so we couldn't solve for anything with this now. We could solve this through simultaneous equations. We'll come to that in a separate video. But in this case then we've got S, we've got U, we've got T, we can find out this T squared term here, and a half is a constant. A is the only thing missing, and we're asked to find A, the acceleration of the car, so we can do that. So this is the equation that we're going to use then. So S is equal to UT plus a half AT squared. So we start filling in some values now. S is 110, is equal to U, which is 0 by T, which was 5.21, plus a half times A times, and our T squared here, the time is 5.21 squared. Common problem, people forget to carry down this square onto the next line, or write this out, but forget to actually square up this term when they're doing it in the calculator. Right, 110 here is fine. Over here we've got 0 by 5.21, so that's going to go. So our next line is going to be 110 is equal to, and we have to square this 5.21 term. So let's do that out. Squared is going to be 27.14. So that's a half times 27.14 A. That's squaring this. I'm doing this in steps so that you can see what's happening. 110 then is equal to, well, a half by 27 is 13. This works out as 13.57 A. Now we want A on its own, so let's swap these over so that the A term is on this side. We've got 13.57 A is equal to 110. And we want the A on its own, but it's multiplied by 13.57. So let's divide that by 13.57 to get rid of it. And of course, if you're going to do it on this side, you have to do it on this side. And what will happen here is they'll cancel. You'll be left with a on this side, and then here you divide 110 by 13.57. So overall, your answer is going to be a is equal to 110 divided by 13.57, which gives you 8.11 meters per second squared, and you need to make sure you have those units correct. We started with SI units, so if we finished with SI units overall. We've got an acceleration, and the units of acceleration are meters per second squared.